And I'm going to film this just because this part can be just a slight bit mind-blowing, so I want to record it. Okay. Now, at the end of the day, we're going to simplify it all. But to get you guys to see what the hell it's all about, there's some complexity that we have to go through, and that's going to involve me drawing. And so I think the easiest thing to do is to record that, and that way I can throw it up there for you guys to look at your leisure. So let's go ahead and talk real quickly before I start getting all crazy in my drawing. Let's talk about Einthoven's triangle. You guys remember Einthoven's triangle? Yeah. Okay, so let's just draw that real quick here. All right, so there's the triangle. Everybody's cool with that?
Yep.
Okay, what does it represent?
The leads and directions to go.
Okay, so what electrode is this here?
One.
Well, what electrode?
Oh, right arm.
Okay, this is the right arm. All right, this is the left arm, and then the LL. Okay, cool. So what lead is represented here?
One.
Okay, this is lead 1, and what direction?
To the right arm. To the left, LA.
Okay, so the LA is the positive, and RA is negative. You guys cool with that? All right. What lead is 2, or where is lead 2?
Right arm, left leg.
All right, and then right arm's negative or positive?
Negative.
It's negative, positive, and lead 2 looks in that direction there. You guys cool so far? All right, hopefully it's just a review. And how about lead 3?
Left arm to left leg. Down.
Okay, left arm
negative.
to left leg. So this is negative, and this is positive. It looks in that direction there. You guys cool with that?
Yes.
All right. Now, we're going to use this to build upon a concept known as axis. So what the heck is axis? Well, axis, the cardiac axis, is the mean or the average direction of all the depolarization of the heart. Okay? And how we determine this, how it's actually determined with the ECG, is if you look at the heart. All right, I like this drawing of the heart, so I'm going to keep this so when the art gets real crazy. But I'll draw you guys a new heart here. All right. So let's talk about how the conduction happens through the heart. Okay, so it starts up here in the SA node, right? And then what happens?
It goes down.
Right. Well, it goes out through the atria, through the intranodal pathways, right?
Yeah.
So it goes out in all these different directions. Does that make sense? And each direction can be thought of as what's known as a vector. Has anyone ever heard of the term vector? A vector is something that has some sort of magnitude, okay, and it has some sort of direction. So the magnitude is kind of how much electricity there is involved, if you will. Okay, and then the direction, you of course you know what the direction is. And so if you had to guess, is the magnitude of these vectors very large in the atrium?
No.
Not really, right? Because it's just a little P wave, right? So do you think they contribute a whole lot to the overall vector of? No, not really, but they do contribute a little bit. So you have them move out, and then you have the AV node, the AV junction, the bundle hiss, and all that, right? And then where does the impulse go? Okay, it goes down the bundle branches, okay, through the fascicles, out this way, and then kind of this way here. You guys cool with that? All right. So far, so good? Okay, so what we do to find the axis is we add up all these vectors here, and we get what the average vector is. And the way that adding vectors up, you can think of adding a vector kind of like this. So imagine, if you will, that I have my point of origin here, and from that point I have a vector, and the length of the vector is the magnitude. So how long it is how much voltage, for example, how much potential is involved. Okay, and it's in this direction, and then I have another vector in this direction, like that. You guys cool with that? And I want to know what's the average vector. So all I do is add these up. And the way that we can do this without really resorting to a lot of math is imagine that I just make a triangle out of this here. And then the new arrow at the tip of the triangle is these two vectors added together. Does that make sense? Mm-hmm. And you can imagine, okay, imagine that I have maybe a ball here. And I have a ball, and it's like a metal ball. And I have a little person pulling on the ball in that direction. What way is the ball going to move? It's going to move in this direction. Let's say that I attach another wire to that ball, and I have another guy over here, and he's going to pull in this direction. So this guy pulls in this direction, this guy pulls in this direction. What is the overall direction that the ball's going to move in?
In the middle.
In the middle.
There you go, right? You make a triangle, and the overall direction of the ball is going to be like that. Is everybody cool with that? Does that make sense? That's pretty much what we do with the heart. We add up all the little vectors, and we get an average vector. And if you had to guess, what would that arrow, if I were to just draw an arrow to represent the average direction in which that depolarization would be?
This. Tip of the...
Like this?
Yes.
And you guys would be so wrong. No, you're totally right. Yeah, totally right. Okay, is everybody cool with that?
Yes.
So in a normally functioning heart, you can imagine an arrow going through the heart like this. Is everybody cool with that? Mm-hmm. And then if there are abnormalities, that arrow can shift different directions, right? If something abnormal happens. The direction of this arrow that I drew here is known as the cardiac axis. Is everybody cool with that? So when we talk about the axis, that's what we're talking about. So is everybody okay with that so far? No, keep your hand down.
I'll just
Keep
keep
it
it
down.
question.
No, go ahead.
Einthoven, so let me done, and one of the guys in the paramedics said that anyone who's a taller guy, their heart sits on a slightly right axis.
Yes.
I know they're explaining to me why that is. They just say it is.
It may become out if it doesn't become answered today.
Mm-hmm.
Ask me. Make sure you ask me again. But I think maybe as we go through this, you'll kind of get a feel for what's going on there.
Okay.
Yeah. Okay. So you guys cool with that? So far, right? So far, you guys following? All right, cool. So now what we need to do is we need to develop a set of coordinates to talk about axis, right? Because everyone agrees that that arrow is normal, but what would we make normal? What would we call that normal? Does that make sense? We've got to call it something. We've got to put some label to it. So this is what is recognized around the world, okay? It could have been some other way of doing it. Okay, it's completely arbitrary how we came up with the numbers, but we had to assign some values. Does that make sense? So this is how it happened. So what we're going to do is we're going to go back to Einthoven's triangle here, and you can imagine that Einthoven's triangle is making a triangle around the heart. If I draw the heart as a circle, you guys cool with that? So what we can imagine is, if I look at lead 1, okay, what direction is lead 1 going?
To the right.
Okay, it's going right through the heart in this direction. Is everybody cool with that? So what if, because lead 1's the first lead, right? What if I were to base my axis off of lead 1? Just start at lead 1. You guys cool with that? And I'm going to assign a value to lead 1. And I'm going to say that lead 1, because we're talking about a sphere or circle around the heart, it makes sense to talk in degrees. Yeah, because you're going around a circle, right? So why not start at 1, and let's just call 1 0 degrees. You guys cool with that? We're just going to start there. We're going to say, okay, lead 1 is 0 degrees, right along that lead. You guys cool with that? So far, so good? All right. And then let's now add some limb leads in here, or some augmented leads, AVR, AVL, AVF. You guys cool with that? And those are combinations of these limb leads here. All right. So what lead do you suppose this one is here? This is AVF, right? Coming right out of the front. Imagine it coming right out of the front. AVF. And AVF is what to lead 1? So if I draw a line like this, it's perpendicular, right? It is at a what angle to 1? 90-degree angle. So why not just call AVF 90, positive 90 degrees? Are you guys cool with that? And I'm going to call lead 1 0 degrees. All right, so from 0 to positive 90 degrees. Are you guys cool with that? Is everybody okay? I don't want to lose anybody early in the game here, so I'm just going to build it up slowly. All right, now let's look at lead 2. Where does lead 2 go here? Okay. In relation to 1 and AVF, where would you think lead 2 is going to be? 45. Close. Not quite, but you're on the right track. It's going to be at an angle to those two, right? It's not perpendicular, but it's going to be at an angle. And lead 2 is going to be at is going to be at plus 60 degrees. And does that make sense? There's lead 2. There's lead 2. So let me draw that a little better for you guys here. There we go. I'll even put some sound effects in there. Plus 60 degrees. So you can just imagine another line here that's going to be plus 30 degrees. So you have 0, 30, 60, 90. Are you guys cool with that? Everyone cool? So I've got 2, I've got AVF, and 1. All right, you guys cool with that? And why not just throw in 3 for the sake of completeness? Are you guys cool with that? So what direction does 3 go?
It'll be 120.
Ah, you guys are right there, aren't you? Lead 3 is a reflection of lead 2 coming out that way, and it would be positive 120 degrees. And then you could imagine another reflection of this would be positive 120, 150, and then right here would be 180. Yeah, I'm going to put plus or minus 180 degrees. Are you guys cool? Are you guys okay? So everything from 0 down up is positive. Do you guys see how that's positive? So what do you suppose everything on top is going to be? We're going to make it negative. Again, it's completely arbitrary why we do that. We could have made it positive. We could have made this positive and this negative. That's just the way it happened. Is everybody okay? There's no special secret or anything like that. That's just how we define this axis. So you can imagine what would way up here be? Negative 90 degrees. Okay, and then what would this be? Negative 30. And then this would be negative 60 degrees. All right, you guys cool with that? I haven't lost anybody, have I? No? Okay. So what I'm going to do now is I'm going to take this axis, this coordinates that we derived from Einthoven's triangle. I'm going to take these coordinates and I'm going to put that system right on top of the heart. You guys cool with that? So imagine, if you will, that I just draw a line. It's not quite center. Let's try to center it, because we're going to pretend that the heart is a big circle, okay? Even though it's not, we're going to kind of pretend. So I'm going to say the center of the heart is, you guys cool with that in back? And you guys see that okay? Yeah. All right, so I'm going to say that this is the center of the heart here. I'm going to draw my lines. All right. So I've got a big circle that I've made around the heart here. I'll draw that for you. You guys cool with that? So let's fill in the circle. So what's over here?
0.
0 degrees, and what lead is this?
Lead 1.
This is lead 1, okay? What's up the top here?
-90.
-90 degrees, okay? What's down here?
+90.
+90 degrees, and what lead is represented here?
AVF.
Augmented vector front, augmented front vector, AVF. All right, you guys cool with that? Where's lead 2 here?
60.
All right, so it's going to be a little closer than 90 here, so let's draw that. You guys cool with that? We're going to say that this is +60 degrees, and this is lead 2. All right, so I have 1, 2, AVF, and what's the other lead that we want to talk about a little bit?
120.
Right, 120, which is going to be a reflection of this one here, and this is going to be 3. And that's 120 degrees, and I'll put positives here. Those are all positives, okay? Are you guys cool with that? Does that make sense? All right, so this is the axis system that we use. So if you had to imagine where degree-wise is my normal axis more or less going to be?
60.
Right around here on 60, huh? Are you guys cool with that? So positive 60 degrees is more or less the normal axis. That's normally what we would see. And does it come as any surprise that what lead do we often do monitoring in?
2.
Lead 2. Does that come as any surprise, knowing what we know now? Not really. Lead 2 is a good lead because it generally looks right along the mean cardiac axis. You guys cool with that? So it's really good at looking at like finding ventricular dysrhythmias, which is what we do with rhythm strips. Okay, cool. So we've got our coordinate system here. So our normal axis, okay, I'm going to throw some values at you guys, and then I'm going to show you how we can look at 12 leads and figure out what's going on, okay? So your normal axis, okay, your normal axis is -30 to +90 degrees. All right, so let me just draw the normal as red. So what did I say?
-32 + 90.
All right, so I'm going to just put an invisible line here, -30 degrees. All right, -30. So maybe I'll make normal red. You guys cool with that? -30 to +90. All right. So if that arrow is in this range here, this is considered normal. You guys okay with that? That's normal axis. Now there is a subset of normal. There's a subset of normal that is slightly shifted upwards. All right. And if you look at the heart, what side of the heart is this here? This is the left. What side of the heart is this here?
Right.
So if I shift upwards, my axis is going to deviate left axis. And if I shift backwards here, it's going to be right. So between 0 and -30, okay, is called physiological left axis deviation, okay, because it's still within that general normal range, okay, and perfectly normal is between 0 and +90. You guys okay with that? Everybody okay? Maybe I'll just write. So perfect normal is from 0 to +90 degrees. All right. Physiological left axis deviation is from 0 to -30. You guys cool with that? So far, so good? Okay, cool. All right. And,
Did you just say the normal axis is -30 to +90?
yes, but physiological left axis deviation is a subset of normal.
Oh, you put 0
yeah, 0 to 90, 0 to positive 90, right?
Oh, that's absolutely.
Perfectly normal.
Okay, excuse me.
Perfectly normal, and then you have from 0 up to negative 30, which is normal, it's normal-ish, but it's what we call physiological LAD. So we're not as concerned about that, if you will. This is like our wiggle room here, if you will. I'm sorry if I confused you. That's cool. Okay, you guys good with that? So far so good? Okay, so we've got perfectly normal, well, perfect normal, we'll say perfect, is 0. Oh, I put that there. Yeah. Perfect. Alright, cool. You guys cool? Tracking so far? Okay, cool. So, we've got normal and we've got physiological left axis deviation. So let's now talk about pathological LAD. And where do you suppose pathological LAD is going to be?
In the areas we haven't talked about,
Okay.
90 to 120.
Negative 90 to.
There you go. Yeah, you're close. Negative 30 to negative 90. So up here, and I'll draw this in blue, this is going to be patho LAD. You guys all right with that? So patho left axis deviation is going to be from negative 30 degrees to negative 90 degrees. So far so good? All right. Let's fill in some more. What's this right here?
Negative.
Yeah, plus or minus 180 degrees. So what's back in here?
Extreme right.
Yeah. So what is, let's see here, negative 90. Draw a line here. Just doing this for the sake of completion, those two lines there. So what degrees do you suppose those two lines fall on?
Negative 120.
Negative 150. You guys are all over this. All right, you guys cool with that? That's just for completeness, so we can see the whole circle. Okay, so we've got normal, physiological LAD, and pathological LAD, or left axis deviation. All right, so let's now talk about right axis deviation, which is in this area here. So let's just talk about your run-of-the-mill right axis deviation, okay? And that's going to be, what do you suppose? Close.
60 to 90 to 120.
How about 90 to
180.
180, okay? And hopefully there's still a bit of color. Yeah, oh yeah, cool. I'm trying to do different colors for all these to kind of color coordinate it for you guys. So this right in here is all RAD. You guys cool with that?
It's not patho, it's not.
No, we just call it RAD. It is pathological. Okay, it is pathological, but it's not a subset of normal. There's no physiological RAD, if you will. You guys cool with that? Yeah. All right. And then finally, back here, from plus or minus 180 all the way up to negative 90 is what we call extreme RAD, or some people call this right shoulder deviation, or a lot of people just call this no man's land. No man's land. Alright, so let's fill in the blanks here. So RAD is going to be from plus 90 to plus or minus 180 degrees. You guys cool with that? And then finally, no man's land, or your extreme right axis is going to be from minus 180 degrees to negative 90 degrees. All right. Are you guys cool so far?
I got a quick question.
Yeah, go ahead.
On this triangle over here,
Mm-hmm.
what exactly am I looking at? I understand that this is like a disc that I put here.
Mm-hmm.
What is that triangle? What am I looking at?
The triangle?
To
You're
take
looking
that
at-
triangle out,
Uh-huh.
how does it lay on?
Just
Same-
like that.
same way?
Yeah, just like that. So basically what you've done here is I've turned this triangle into this.
Okay, so they're both kind of on the same plane.
They look exactly the same thing. It's just that I've transformed this triangle into a circle so I can have a degree. I can make my degrees. But this is basically, that's what I did here is I said, okay, imagine that 1 points at 0, and then 2 and 3, and then ABF.
Okay.
And I just took those and I went to here, and then I built this from here, and then I put this on top of the heart.
Okay, this is why I asked this, is that based on what you just said, that tells me that if I take the leads
Mhm.
and I put them here instead of here
You reverse them?
no, I mean, if I put the leads here in the front
Uh-huh.
instead of like right smack dab in the middle, and
Uh-huh.
here instead of here,
Uh-huh.
I'm gonna get an altered picture.
It might a little bit.
Okay.
It might a little bit, but still, it's looking at the average axis.
Okay, so it doesn't matter all that much.
Yeah, it might just a little bit. Okay, so yeah, you're right. If something was maybe a little on the line and you ran it, it could push it up into the, if something was maybe physiological, it might push it a little up into the pathological.
So you wanna get it as in the middle here as
Yeah,
possible.
what you want to do is whatever the manufacturer of that device tells you to do, that's how you do it. So,
Oh, that's a cop-out, Chris.
it is a cop-out, but it's it's how they designed them, it's the best thing to say.
All right, you're right, it's the best thing to say.
But did that answer the question?
Yes, it
more?
did.
Okay,
Thank
cool.
you.
Yeah. All right. Is everybody okay up to this point? So far, so good? All right, so now what I'm going to do is I'm going to add another layer on top of that. Does everybody have their piece of paper?
Yes.
All right, what I'm going to do is I'm going to pass this 12 lead around. And yeah, hopefully there's enough. I may think I made an extra for myself. If not, you guys are just going to have to give me the information and I'll walk you through it. And I will be talking about what causes right and left. I just want to make sure we're okay on how to identify it. Or what's going on.
I'm just kidding.
Okay. All right. So I've got a 12 lead ECG there, and we have no idea what the axis is yet. You guys cool with that? So what we're going to do is we are going to try to determine the axis.
Never mind, missing all the writing on top of the degrees.
Yeah, I know. Sorry. Sorry about that.
Okay. Yeah.
I did too, I was like,
Yeah, you're looking for the. But we will get to the point where we're looking at the writing on top, because yeah.
Oh, it was upside down.
How about that? Everyone got one? What? Everyone good? Everyone's good? Got it? Cool. All right. So let's determine the axis of that 12 lead that I gave you guys. And what we're going to do is we're going to look at those leads. So what lead did I use to set the whole coordinate axis system up? Lead 1, yeah. So I started at lead 1, so why not just start at lead 1? What the hell, huh? So I want you guys to look at lead 1. It looks normal. And what is a QRS complex doing in lead 1?
Positive.
Is it positive or negative deflect?
Positive.
Okay, so now we're going to start putting everything that we've been learning together. If the ECG, the QRS is mostly positive, okay? It's mostly positive, greater than half of it's positive. Where is that impulse moving? Is it moving toward or away from the positive electrode? Toward the positive electrode. Are you guys cool with that?
Mm-hmm.
So what are my electrodes for lead 1? Negative. Okay, so negative to positive. So if it's positive, what that means is it's moving toward lead 1. Are you guys cool with that? It's moving toward lead 1. And did everyone draw this? And has everyone got this?
I did not draw it.
Okay, because I'm about to kind
Are
of.
we supposed to draw it on the paper?
You don't have to, but you will be
Can we just take a
drawing,
picture?
you can take pictures. You're gonna be using this picture later on today to actually do your own drawings and do your own interpretations, so if you don't have that down, do you need a minute to kind of?
Yes.
Yeah,
Okay.
I thought we were saving this for something special, this paper.
No, that's for you guys to draw all over and to take notes and whatever. And is there a picture, there should be a picture, is there a picture of this in the book? I hope there is,
Kind of.
in the ECG book? Oh.
The orange book has sections of this.
Yeah, the problem with the books is that it's all over the place and I wanna bring it all together for you guys in a nice little package here. Alright, so, let's go ahead and rock and roll with this. So what I'm going to do is, I am going to draw a line. I'm going to go to lead 1. Okay? And I'm going to draw a line that is perpendicular to lead 1. So what line would be perpendicular to lead 1? That would be this line here, right? You guys cool with that? So what I'm going to do is I'm going to draw a line. And I'm going to have an imaginary line here. Alright? So I'm looking at lead 1. That's my imaginary line. You guys cool with that? And then I'm going to ask, is the QRS up or down? It's up. So if it's up, it's moving to the positive electrode in this direction. So just by looking at lead 1, if lead 1 is up, then my axis is going to be somewhere in here. Somewhere on this side. Are you guys cool with that? Everyone, so far so good? Making sense? If lead 1 was negative,
Be on the other side.
my axis would be somewhere potentially over here. You guys cool with that? So I just basically cut my circle in half by just looking at lead 1. Okay, so now what I'm going to do is I'm going to look at other leads and I'm going to narrow the axis in. So now let's look at lead AVF. Okay? And what is a line that's perpendicular to AVF?
The 0, 180.
Yeah, I'm going to draw that in red. So right here. Alright, so, and again, I'm going to say, is it positive or negative?
Negative.
Positive.
Which one?
Look at AVF,
Oh,
positive or negative?
Moving downward towards a positive.
Negative deflection.
So,
But it's moving toward a positive.
what do you guys think?
I don't know.
Goes that way, top.
AVF is,
Going up.
Going up.
Oh, it's positive.
right, AVF moves in this direction, right? Okay, and QRS is,
Negative.
look at AVF on your paper, is it positive or negative?
Negative.
It's negative, so, am I moving this way or this way?
Up.
Up. Are you guys okay with why I'm going to draw up in this direction here? Okay. Well,
Can you
what's
say it one
confusing
more
about
time?
it is that
all right, let's go through it one more time. So, lead AVF. You guys found it on your 12 lead?
Yes.
You found it here. I'm going to draw a line perpendicular to AVF. That's this red line that I drew here, okay? And now I'm going to ask myself, is the QRS moving toward the positive electrode or away from the positive electrode?
So the positive electrode over there is down. And the deflection is down.
So
So
it's
that means
moving to
positive?
the negative.
Okay, that makes sense.
See here?
Away from the positive.
That's why I wanted to review Einthoven's triangle first. So you guys are cool. You guys cool?
No, I'm
Why?
lost now.
Because of the isoelectric line.
I think
it's
because
It's moving down, which is
Look
a
at
negative
Look at the
deflection.
QRS on AVF. What direction is the QRS moving?
Down.
It's moving down.
Negative. Moving negative.
So if it's down, it's moving away from,
The positive.
right? So the impulse is moving in this direction, right?
Okay.
Because AVF looks in this direction here, right? So if it was up, it would be looking this way, the way that AVF goes.
Okay.
But because the QRS is down, you're looking in the opposite direction, up this way here.
Just so you might clear up a little, the
QRS
Sure.
has a negative deflection, instead of saying up and down on the QRS,
Uh-huh.
so if the QRS is negative, it just, because when you say down, I think everyone was like, oh, it's going down here.
Okay, negative deflection,
Yeah.
okay.
It's
I'm
moving
okay with
towards
that.
negative.
Yeah. So
Yeah.
it's moving toward the negative electrode, the negative electrode. Are you guys cool with that?
Yes.
Is everybody on the same page? Okay, cool. So I'll say negative deflection, is that what you guys,
Yeah.
does that
It helps
sound better?
a little
Okay.
bit.
So the QRS is deflecting negatively or away from the normal way that it goes, right? That's why I drew the arrow there, it's moving this way. So because it's moving this way, I am going to draw up in this direction here, right? So I have narrowed this yet some more, haven't I?
Yes.
By looking at just one in AVF, I know that the axis has to be somewhere between 0 and negative 90, right? So it's either physiological left or pathological left, right? Somewhere in here. So what I'm going to do now is I'm going to look at lead 2, okay? So I looked at lead 1 first, I looked at AVF, and now I'm going to look at lead 2 for my tiebreaker. What is perpendicular to lead 2?
Negative 30 and
Okay, so this line right here. And is lead 2 up or down? Or negative deflection, sorry. Negative deflection, so am I gonna go this way? So what is the axis?
Pathological
It
left axis.
has to be pathological left axis deviation. You guys see that?
So you only used one AVL and two.
One AVF and 2, yes.
Okay.
One AVF and 2.
Kept you on that side.
Yeah, and all the colors fell. There's only one area. You guys remember doing Venn diagrams?
Well, I get that. I just-
Right, you draw circles, you do little Venn diagrams, and what circle has all 3 colors in it? That's all we're doing here. All 3 colors meet pathological. Yes, sir.
So when you're looking at the QRS, you're taking the general direction as far as if most of it is negatively.
Yeah,
deflected
if
towards-
more of it is negative than positive, then you say that it's
Is there
negative.
gonna be a time where like, I don't know, it's gonna be.
Yeah, it might be right on the line, and then in that point, you just go negative, generally is what I kind of go, because that makes it worse. It's kind of like, well, that's the worst case scenario. Are you guys cool with that? So what I'm gonna do now is, I'm gonna get you guys in a break, because I think,
You saturated.
yeah, you guys got saturated. I'm gonna give you guys a little break, and then what we're gonna do is we're gonna come back together, and I have several 12 leads that you guys will break out in small groups, and I have got some wrapping paper that we're gonna put on the wall, and you guys are gonna draw this, and I've got even some nice colored markers there. You're gonna draw that, and then I'll have you guys actually do the colors and figure out what the axis is, and you'll just do exactly what I did here with you guys. You guys cool with that? All right. And then, once you do that, I'm gonna show you something that'll make it so easy that you'll never have to worry about doing colors again. But I wanna do the colors first so you understand what the axis actually represents. All right, get out of here, take a little break. I'll see you in a few.